In this video, we're going to be looking into depth limited search. This algorithm is very similar to depth first search algorithm. So let's take a look at this with an example. Like all algorithms, you have to define a source node and a goal node. Here I've taken A as my source node and F as my goal node. You also have to define something called a depth limit here, which I've taken as 2. You also have to number your graphs with levels, where you start from the topmost as 0 and proceed downwards. Since I have 4 levels here, I have numbered it from 0 to 3. This is very important because this helps you decide the depth limit. So, since my depth limit here is 2, it means that I can only traverse from level 0 to level 2, which means I cannot traverse through any node which is in level 3 or below, but since I have only till level 3, so I cannot traverse to level 3. This is convenient for us because our goal node is present in level 2. So we don't have the need to traverse through all these nodes in order to reach this node. So for us to find the goal node, this it will be much faster than compared to if you were using a depth first search algorithm where you had to traverse through all these nodes to reach the F. Okay, so now we'll start off by taking our source node A. So from source node A, I can travel from either B or C, but I've chosen to travel to B. Now, after I travel to B, I can go to D or E, but I'll just go to D. So after D, I cannot go past D because my level limit, the depth limit is 2. So I cannot go to level 3. So I stop here. I do not go further down. So I will try to backtrack now. So I backtrack from D to B, and from B I check if there's any other node. In this case there is, which is E, so I can travel to E. Now after E, I can only travel to I, which is in level 3, but I am not allowed to go to level 3. So I will backtrack again. Now I'll check B again. Is there any other new node which I haven't traveled to from B? No. So I'll backtrack again to A. Now again I'll check from A, is there any new node? Yes, there is, which is C. So I can travel to C. So once I have traveled to C, is there any other node which I can travel from C? There is, which is F. So once I've reached F, I can now confirm that I have reached the goal node. So since the goal is reached, the search here is over. And it also made sure that I didn't have to travel to these unnecessary nodes in order to reach my goal node. So I have found my goal node in a faster manner.